Hey everyone, this is the first part of your homework. If you are struggling with this table, I'm here to walk you through how to get all of the data on the table. So let's start with just reading the problem. We have Pearl here. Hello, Pearl. And she is walking 10 meters in 4 seconds. So the rate we are working with here is meters per second. So whenever we have a sentence like this, meters per second, this first word is our numerator. The per is going to show us our fraction bar, and the second is our denominator. So we would write that as meters per second. And since we have some information here, we can go ahead and say that for Pearl, for this situation, it is 10 meters. I'm just going to write an M there in 4 seconds. I'm just going to write an S there, just so we know what we're talking about. It's important to always keep our units. Okay, let's start plucking away at this. So assuming she's walking at a constant rate, we need to complete this table, and we can have our answers be fractions or decimals rounded to the nearest hundredth. All right, let's do it. Well, we know right away that if she has walked for 0 seconds, and she's gone 0 meters. And we have right here that when she walked 4 seconds, she went 10 meters. Let's fill out the rest. What we need to know is how far can she go in 1 second? That will be our unit rate. So let's set it up and say, well, we don't know. How many meters, we'll leave that blank, can she go in 1 second? So what we're going to do here is any number divided by itself is 1. Any number at all. So we're going to take this 4 here, and we're going to divide it by 4. And that's how we end up with 1 right there. But if we do that to our denominator, we have to do it to our numerator too. So we're going to say 10. We're going to divide it by 4. And you can use your calculator for that. Just plug in 10 divided by 4. And what you end up with is 2.5 meters in 1 second. We can go over to our table right here. See that when our time is 1, we can now put that our distance is 2.5. Now that 2.5 meters in 1 second is called our unit rate. Our unit rate is when that denominator is 0. So let me go ahead and circle that in red because we're going to use that to answer all of our other problems. That's our unit rate. Pearl is walking 2.5 meters per 1 second. All right, let's do all of this now. So for 2 seconds, if she goes 2.5 in 1 second, then we can just multiply that both by 2. We can say 2.5 times 2 over 1 times 2. That's going to give us 5 meters in 2 seconds. So we can put a 5 right there. For 3, same process. We can say 2.5 times 3, 1 times 3. And we end up with 7.5 meters in 3 seconds. So pop a 7.5 right there. All right, I'm going to skip this one for a second and just move down to 50 because that's the same process. So we'll say 2.5 meters times 50. And then 1 times 50. And again, you're more than welcome to use your calculator. Just plug in 2.5 times 50. And you'll get that is 125 meters in 50 seconds. Let's put that in. All right, now this one is a little bit trickier because we have our distance, but we need to find our time. But we are still going to use our unit rate. We're going to say, well, we have 2.5 meters in 1 second. So how many meters in 1 how many seconds for 100 meters. And we're going to do this in reverse. So before we were multiplying, so now we're just going to divide. We're going to say, well, how many times does 2.5 go into 100? So we're going to divide that way. We're going to say 100 divided by 2.5, and that'll get us 40. So it's 40 seconds. You can also look up to this one at the 4. It was 4 seconds. She went 10 meters and just multiply that. And be like, well, that means for 100, it just has to be 40. Okay, so last step before you can make your graph is we just need to label which one of these is our x and which one of these is our y. And since our x is independent variable, it's what influences what's happening, that means time is x. Time is our IV. Distance is our y, which is our dependent variable. So as you make your graph, you have your y-axis and you have your x-axis. There's your x, there's your y. We're going to have this one be time and this one be distance. All right, I hope that's helpful. Take care, y'all.